morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we're going to talk about quadratic functions. This should be real quick. A quadratic function is a relationship between two variables, which can be written in the form y equals ax squared plus bx plus c, where x and y are the variables, and a, b, and c represents constants, and a cannot be equal to 0. That's extremely important because what really makes this a quadratic is the squared, the exponent 2, the leading coefficient. So it's of degree 2. Of course, we can write y equals ax squared plus bx plus c. It can be written as f of x, the function of x. So nothing real new here. If y equals x squared minus 6x plus 8, find the value of x when y equals 15. So for a, we're going to say 15 equals x squared minus 6x plus 8. Subtract 15, 0 equals x squared minus 6x. 8 minus 15 is what, negative 7? Is that correct? So then 0 is equal to, it's going to be an x minus 7 times an x plus 1, which of course means that x could equal 7 or x could equal negative 1. Easy peasy pumpkin pie. So what about when y equals negative 1? Well, we would have negative 1 is equal to x squared minus 6x plus 8. Add 1 to both sides. X squared minus 6x plus 9. This is going to be a perfect square trinomial. X minus 3, the quantity squared, so therefore x is equal to 3. So this guy is going to intersect, oh, that was horrible. This guy is going to intersect the x-axis in two places, at 7 and at negative 1. It's opening upwards because that's positive. And this guy is going to intersect the x-axis at, it's going to touch the x-axis at 3. It also is going to open up and going to look something like that, where it just touches it there. Okay, so let's take a looky here. A stone is thrown into the air. Shake it like you just don't care. Its height above the ground is given by this function, where t is time in seconds. So if I know the amount of time, I can see how high h of t the stone is. A, how high is the stone above the ground at time t equals 3 seconds? So I'm just finding h of 3. So that's going to be negative 5 times 3 squared plus 30 times 3, 3 plus 2. And that, of course, is equal to 47. So that's 47 meters above ground at time, what was it, 3 seconds above the ground. Very nice, very easy. B, from what height above the ground was the stone released? Okay, well, the stone was released when time was equal to 0 seconds. So that implies I need to find h of 0. And if you look at here, 0 gets rid of this term, gets rid of this term. So that's going to be 2 meters above the ground, right at the very start. And then finally, they want to know at what time is the stone's height above the ground 27 meters. So they're telling us that h of t is equal to 27. So that means it has to be equal to negative 5t squared plus 30t plus 2. I'm going to move all this over to this side so I don't have to deal with a negative 5t. So that would give me 5t squared minus 30t plus 25 is equal to 0. I see a common factor of 5 there. So 5 times t squared minus 6t plus 5 is equal to 0. So then I have 5, let's see, that's going to be t minus 5 times t minus 1, coolie mama, equals 0. So that would be t equals 5 at 5 seconds. And t equals 1 second. Well, what does that mean? Well, that makes perfect sense because you're going to be throwing your the stone. It's going to travel in the shape of a parabola. So at 27 meters, could be here and here, whatever that time is. So this would be like 1 second if this was along the x-axis, right? And then right down here would be 5 seconds. All right, hope you enjoyed that. We will get back and see how Coldplay is doing. Beautiful song. And with that, I shall say that I am out.